Hello everyone, I'm Jay, your host at Everything Cloud Platform. Welcome to this session on building observability for your apps running in GKE, the Google Kubernetes engine. We'll introduce a couple of containerized microservices running on GKE. We'll then induce some load on these microservices and use Prometheus, Istio, and default GCP logging to build the golden signal dashboards. Both GCP native and using a third-party tool like Grafana. So let's go. Here are the steps that we are going to be following in the session today. We'll review the GKE cluster up and running. We'll do a quick overview of the demo apps that we'll be using, our number wiki and math functions app. We'll walk through the Kubernetes YAML configuration files for these two apps. We'll deploy the apps using kubectl from the CLI. We'll validate the apps and then induce traffic. We'll review out of the box observability dashboards available for GKE. There is a lot that is available out there. You should look at what is available and then build what does not meet your need still. And then finally we'll build our golden signal dashboards using for both GCP native and Grafana. Here is the link to the video that talks about creating and connecting to a GKE cluster. In the example, we have used autopilot cluster, but you can apply the same process to standard cluster as well. That walks you through the networking and IP subnetting considerations, which is a very important part of creating a cluster. You will need to have the appropriate IP CIDRs ranges and subnets applied to the pods, the services, and the nodes, and all of that configuration settings are important when you go about creating a cluster. That's what the video talks about. We also enable Anthos service mesh for the cluster. We discuss the authorized networks for the cluster, and then eventually we connect to the cluster from your laptop or from a VM running in the authorized network. Here is the link to the video on your screen. Let's look at the cluster that we have already created. We have an autopilot cluster that is already out there. And here is how the cluster looks like. Here are some of the cluster basics, like the name of the cluster is SRE, and all these configurations that we set up as we were creating the cluster. A couple of important things, a few important configurations that I'll point out here are, say this is a private cluster, one of the security best practices. Look at some of these IP range configurations, like for the pod address range, it's a 10.125/16 IP CIDR range. For services, you have 10.126/17 subnet. Then the authorized networks and so on and so forth. And all of these settings we did as we were creating the cluster. One more important thing here would be look at the Anthos service mesh. That is enabled by default. If I just search for Anthos, yep, you'll see that this is provisioned and it is enabled. So that's how our cluster looks like. Take a quick peek at, say, if I do a kubectl get ns, right, that gives us all the namespaces in the cluster so far. If I say run something like kubectl get all, this just, when you do a kubectl get all, it gets all the resources like the deployments, pods, services, or whatever there might be. Notice that we haven't provided any namespace here. So by default, it pulls everything from default. So default is the default namespace that the kubectl commands run against, and we can change this. We will change this once we create our resources. Right, but this is the default setup. So if I want to get all for, say, GKE GMP system, I'll have to provide that -n switch and then provide the namespace name, and then it pulls everything, like all the services and all the resources in GKE GMP system. Some of these namespaces are Istio related, and the managed Prometheus, and so on and so forth. Let's look at the two apps, two microservices that we will be working with throughout this demo. Now on your screen, you're seeing a VS Code window broken out in three different columns. On the first column, we have the number wiki app. So, and in the second column, you have the math functions app. So those are the two microservices we are working with, number wiki and math functions. And this is where we'll be running these two applications. So you see the functionality just to get familiar, and then we'll get into details. So what I'll do is just run the application here. So this runs on port 8081. Number wiki is running on port 8081. I'll run the math functions app, and that runs on 8080. Now both of these are running. Take a quick peek. If I do a curl localhost on 8081, that should run the number wiki. We just got the message there, right? This is an API that exposes this only one endpoint, and let's see what that endpoint really does. Or before getting into that endpoint, let's take a let's just test our math functions as well. The math functions API enables all of these endpoints. So if it, say if I want to just test one endpoint, say is prime, and say I'm doing that check on 657, yeah, the result is, say, the prime number is not, the 657 is not a prime number, and it gives you all of these details: a user message, what was the base URL that was called, the endpoint is this, host URL is this, and so on and so forth. Just something coming back from the math functions API. Now what number wiki does is, number wiki actually uses calls math functions to calculate all of this. So basically, for every call of number wiki, you will see multiple calls of math functions API, and this is all to demonstrate. And in real world as well, you will have applications. Say if you think about a retail application, say a checkout service will make multiple calls to other services in the ecosystem, and that's what we are trying to demonstrate here as well. And we'll play around with Docker to build all of these applications, and push to Docker registry, and so on and so forth. Now let's see what our number wiki does. So if I do a curl on localhost 8081, that's our number wiki. Now we'll use this endpoint 1 by passing it a number, say 657, right? Pass that number. Now you see this, for the one call, it just fired all of these calls through to math functions API. It first fired the is prime, is integer, is even, get factors, get prime factors, change base, and so on and so forth. And finally, this resulted with an output that you see on your right hand side here. It returns a JSON that gives you all of these values. Input number is 657. Your result is comprised of all of these values, the number itself, and then the wiki list with all of these key value pairs. The first one is even odd, that tells you that the number is odd. Factors, it gives you details around, yeah, there are 6 factors. The number is not prime, and the factors are 1, 3, 9, 73, 219, 657. The prime factors are just these 3, 1, 3, 7, 3. And the binary, the number converted into binary looks like this. Number converted to ternary looks like this, meaning a base of 3. And say the number converted into a base of 36 looks like 819. And this is the user message, and so on and so forth. That's the setup of these two applications. We'll see a lot more around this, but just keep this functionality in mind as you look at number wiki that runs on port 8081 and math functions that runs on port 8080. Let's take a quick peek at the Kubernetes manifest files, the YAML configurations for our demo apps, number wiki and math functions. The first column there is the NS for the namespaces. This Kubernetes manifest is creating the namespace called ECP. ECP is for Everything Cloud Platform. And one of the important labels here is Istio injection. enabled. Now this enables this having that label tells Kubernetes to inject the Istio proxy sidecar in the pod along with your app container. More on this as we get into dig deeper into Kubernetes, but for now just know that your container, your pod, all the pods that we will create are going to have two containers running in it. One, your app container, and two is going to be this Istio proxy, and that proxy basically enables all the networking and the service to service communication, etc., within the Kubernetes structure. More on that when you get into Kubernetes. The second column here is the math function YAML. Now notice that if you look at the kind, this is basically is creating three resources in Kubernetes. One is the service, right? Service is what exposes the application at as an endpoint. Remember from our demo apps that math functions runs on port 8080. So basically you're saying the pods port 80 maps to the containers 8080. So if you access the pod at 80, it's going to eventually connect to the container running at 8080, and that's how you'll be able to get to your math functions app. Deployment is the other resources deployments. This deployment basically results in creating the replica sets and the replicas running underneath, basically the pods running underneath. And some of the configuration that you are seeing is in right here. Notice that the image is the Docker image with the tag latest. Right, that's what we are looking at, and some of these resources etc. are specified here. The third resource that we have created is pod monitoring. Now this is important because this is the resource that pushes all the metrics to Prometheus endpoint, and that's important because that's how we'll be able to build the observability, the golden signals dashboards that we are going to be building later in the session. So that's our math functions. Similar format, number wiki. The only thing that I'll point out that is different here is of course the image. Notice the image that we are using is number wiki with the latest tag. The port is 8081 because we know number wiki runs on port 8081. Another important configuration is this guy here. This is an environment variable that we are setting up here. And notice this format of the service. Now this is important. This math functions.ecp.svc.cluster.local. That's how you identify a service within the same cluster. The service name dot the namespace name dot svc dot cluster dot local, and that's how number wiki will be able to talk to or make calls to math functions running in the same cluster. So that's about our Kubernetes manifests. We'll now go ahead and create the resources. Notice that currently there are no workloads running in this cluster. So if I go to the workload, you don't see anything in here. And if I do a kgns, that's the alias for kubectl get namespaces. We don't see our ECP namespace yet. So let's go ahead and create that namespace here. You can do a kubectl apply -f and the file name, right? That's the command that it basically applies whatever is in ns.yaml. And if you take a quick peek at what's in ns.yaml, here is the code, right? That basically is creating a namespace. So let's go ahead and run that command, and that will create the namespace. Now if I do a kgns, I will see the namespace. Now let's set ECP as our default namespace, because if I want to say do a KGP, which is the alias for kubectl get pods. So get familiar with some of these aliases that are provided in my shared repo, in a public repo that has all of these aliases. So do your setup so that you will be able to use and follow along using some of those aliases. So kubectl get pods, by default it goes against the default namespace. Now we want to change this to using the our ECP as the default namespace. So I'll run this command. See, kcn is my alias for kubectl config set context current namespace. So basically I'm saying kcn ECP that sets so we just modified our context and set the default namespace as ECP. Now if I run kgp, you are running the kubectl get pods against the ECP namespace. Currently this says no resources found, of course, because we haven't really deployed anything. At this point what we'll do is there is a command called kubectl get pods and with a watch switch. So if I do this, it keeps on looking for any changes in the pods, for example, and that's what we are going to be doing next. Now if I do a KAF, now this is the alias for kubectl apply -f and the file name. So kubectl apply -f math functions vm1.yaml is going to create those three resources that we have in our manifest files: the services, the service, the deployment, and the pod monitoring. That's what you're seeing here on the right hand side. Now you're seeing the math functions pod coming up. Currently this is showing you, pending init. It'll take a few minutes because it's going to be pulling the image from Docker and it'll create the pod and bring it up and so on and so forth. Once this completes, you will be able to see the math functions pod up and running fine, and then we'll do the same thing for NumberWiki. Math functions just got created. See that 2x2. Now let's look at what just happened here. If I do a kgp, that's the pod that is running and it says 2x2 ready. The reason it says 2x2 ready is because like I mentioned, there are two containers running in this pod. One is your app, the other one is Istio proxy. And if you do a quick describe, like kubectl describe pod, kdp is my alias for describing a pod. If I do a kdp on that, and if you look at some of the details that you see, I'll just scroll up and walk through some of the details that you see. This is important information for you. These are the labels that we provisioned from our manifest files, some of the resource requirements that we provided from our manifest files. That's the IP. Notice that it's from the subnet 10.125 because we supplied, we configured the IP CIDR for pods to be 10.125/16 subnet, right? That's what you're seeing here. Now important thing to point out would be, like I said, containers. There are two containers running. One is your math functions. That's our application. This is telling you the image that was used to build this container, what port it listens to, and so on and so forth. And the second is Istio proxy. Now that's what enables really all the service to service communication, all the networking, and a lot of telemetry that comes from the Istio proxy sidecar here. Now we are ready to submit the other one. And for that, what we'll do is we'll clear the screen. We'll do a kgp watch, and now we'll submit KAF NumberWiki. This will create our NumberWiki resources. So like you're seeing, the deployment got created, the pod monitoring resource got created, and the service as well will get created. We'll look at the services, and on the right you are seeing the NumberWiki pod coming up. The process is still running. It's still trying to bring both the pods up, and the reason it is taking time is because it's going to schedule or create additional nodes to run our pods. And this is, keep in mind, this is an autopilot cluster. So all of these nodes, look at the left hand side. When I ran the command kubectl get nodes, it gives you all the nodes that are running. In the previous command, this guy was not ready. Now in this command, this one is ready here. Now you'll see these pods getting hosted on these nodes that are running. So it just takes some time, a few minutes here and there, till the time all the machines are coming up. Once the nodes are up, then the process of killing the pods and bringing them back up again, all of that is just fine. Now you're seeing, yeah, this just math functions, this just came up fine, and you'll soon see number wiki coming up fine as well. The apps just came up. If I run a kubectl get nodes again, now a total of 2 nodes are running, and of our pods are running on those. So if I just do a kgp, you'll see that both the apps are running, both look healthy, both have 2 containers running, and that's exactly what we want to see. And if you look at now our workloads, you will see that these 2 workloads are showing up here. Everything good. There are one pod for this, there's one pod for this. If I go into any of these, like if I go to number wiki, you see all the details out here. You should explore everything that you see on each one of these tabs. Observability gives you a lot of information around the matrix concerning with your app, and so on and so forth. So you should look at all the details in here. I'll point out one important thing here. You see these exposing services. That's our external endpoint of the service. That's what we should be able to hit, because that's an external IP. Whereas, well, I'll point out that you do not see, notice this IP. This is 34.75.52.24, ending in .24, and port 80. We'll take a quick peek at the same thing for math functions. And if you look at this one is set up as cluster IP, and that's the configuration that we had in our Kubernetes manifest, because we don't want this service to be exposed from outside. You should not be able to call this service from outside. Number wiki calls it, and number wiki is exposed to outside. So you see that it has an internal endpoint 10.126. There is no external IP, and you can see this in your KGS. So if I do a kubectl get services and the alias is KGS, you see the services right here. Let's test the apps real quick and get induce some load so that we can see some observability around it. So if I do a curl on this, that gives me my number wiki, and that tells you my the version is 1.0, right things that we want to see. And if I do a curl on say 567, that gives me a good response. So that tells me that our app is perfectly running fine, because it's able to get to the math functions as well, and it is able to really run make all the commands. Now at this point, I'll quickly show you. Say we ran this for what number? We ran this for 57. What if I want to look at this in the logs? Navigate to logs, and now there are a bunch of logs. This is just last 10 minutes and you're seeing so many entries. Now you'll need to filter out the right logs. So look at Kubernetes containers. That's what you're looking at. See what did it add here? Resource type equals to k8s containers. Now in here as well, there is a lot running, and this is a part of all GKE auto cluster. So just ignore all of this for now. You'll need all these logs are relevant in production when you run into issues. This is the meat that you will need to look at to really work through the issues that you run into. I'm looking for math functions or number wiki somewhere here, and then we'll be able to filter out accordingly for what we are looking at. All right, here is one entry that I found. And what I'll do is I'll filter by this log name. I'll say show matching entry so that this shows up in our access here. Now notice that we just did our application validation using 567, right? So look at all of these commands, all of these log entries right from, say, first one that got started from here. The number wiki got the slash 567 from here. So this was the first call that was made to number wiki, and then number wiki in turn made all of these 14 15 calls to math functions. It called the slash is integer, is even, then get factors, get prime factors, then a change base for each one of these bases, and that's how it was able to give you all of this output. It was able to give you the even, odd, the factors, the prime factors, the binary, ternary, and all of these were all of these, and this information was consolidated using the endpoint, the math functions call. Right, that's the kind of information you get from the logs that you use to build your observability on. Now we'll induce some load on this so that we can see all of this data in the dashboard. I had these apps running as I was prepping for the demo, so there was some load already running before, and now we'll just do the same thing. It's going to induce the load again. Now keep in mind, we'll need to change the you will need the right service external endpoint. So at this point, let me just get my endpoint again. It is 34.75.52.24. That's the endpoint we are going to hit. So let me change this one here, so that we are hitting the right endpoint, and now it starts throwing the inducing load every so often. On the right hand side, we'll induce some errors as well, and this error is going to be less frequent as compared to our actual traffic, and I'll make sure I'm hitting the right endpoint for the 404s as well. Just do this, and it starts throwing. So our load test is running, and we'll see some of this is in action as we look at the observability. Take a look at all the observability available to you by default. If you navigate to dashboards in monitoring, you will see a bunch of GKE related dashboards like this one, workload view, cluster view, and I haven't built these one myself. You're seeing custom here, but I have imported these. If you look at the sample library, navigate to Kubernetes down here, GKE, you'll see all of these, and you can very well just import these into your setup. So the key ones that I'll point out of the box ones that are very interesting ones for GKE are these. Like the first one is the one that is called GKE. You'll see all the nodes here. Now these nodes in autopilot clusters are managed by Google, but then if you have a standard cluster, you are managing all these nodes, and hence all of these matrix that you see, the saturation matrix around CPU, memory, disk, all of these are going to be very important. These are our workloads. Now you're seeing some of these other workloads that are system related. You see math functions, number wiki as well, which are our workloads here. You see some of these error logs, etc. These are from the load that I have been running on these apps prior to the session beginning. You'll see all kinds of things. These are our two pods running that are showing up. These are the containers. We talked about Istio proxy running as a sidecar in each one of our pods. That's what you're seeing. So a lot of good information that you will see here. Then you should look at this GKE cluster monitoring as well. It'll give you a lot of saturation metrics that will help you have your required monitoring alerting on your infrastructure. You should be able to build alerts as needed for each one of these metrics. Compute resources cluster view, another very good piece of information. You see how the charts, these charts are built. This one is giving you CPU utilization percentage over whatever time frame that you choose to run this for a lot of saturation metrics on the top, CPU usage by namespace, the memory usage by namespace. A lot of good information just coming out of the box. Point out to the node view as well. This is your infrastructure health, everything pertaining to nodes, and this is your workload view. Very important from workload standpoint. You have a total of 46 pods running, 73 containers within those 43 pod. You're seeing a lot of pods. Remember when we did all the namespaces, there are a bunch of namespaces in there, right? These systems. Ours is just ECP, and I should be able to just filter this out for ECP. ECP, we know that we have 2 pods and 4 containers, right? 2 pods are like 1 pod each for math functions and number wiki, and each one of them are having 2 containers running underneath it. And you will see a lot of good information around CPU, memory, etc. For our pods. Now we want to build some specific golden signals like traffic, error rate, availability, latencies, and that's what we'll see next. Let's take a look at the golden signals dashboard for GKE. Now this is custom built. This is what we have built, and I'll walk you through each one of those 4 standard availability and latency related metrics that we have been building for our GCE use case, Cloud Run use case as well. Let's look at this. How did we get to this metric? Let's take a quick peek at this one. Look at this Prometheus target, Istio request total, very important metric. Majority of your availability and latency related metrics are going to be available using this metric alone. So this is all of your traffic, and we have aggregated it by destination workload. You can aggregate it by a lot of things here, by pod or the service name and so on and so forth. So when you get into production, you will notice that all of these will come very handy. Currently our setup is very simple, just 2 apps running, but in production, in real life, you will have multiple microservices running, in some cases 80, 100, 200, so this comes very handy. And some of these you'll be able to set up really well. Like I have used legends, these labels showing up, right? Because coming from this, you will be able to add legends. You can add, say, y-axis label. If I write requests per second here, that shows up right here. So you can do some of that here, but important part is that's the matrix that's the metric that we are going after. And take a look at traffic, good versus bad. Again, we'll be going after the same metric, but now notice that we have filtered it. So for our A is good request, because it's looking for response code 200, and see the different values that are available here, like everything coming from the logs, right? And this one is all the response code not equal to 200, right? So the blue line is good request, and the green line are the bad requests. And good request and bad request, we have provided those labels in this legend here. Right, that's how we went after doing the good versus bad request. Availability is total good events over the total events, and then we have added a threshold line as well. Take a look at how did we do it. The first one is a ratio. So A is all the good requests, meaning equals to 200. B is all Istio total requests, and no filter applied. So that gives you all the total requests. And this is a ratio, and GCP provides that capability to create a ratio. And ratio, what we just did was A over B, and we called this availability. That's how you're seeing that availability number in the blue on top, and that is showing up on the right axis, and we have labeled it as availability as well. And then we added this C, which is actually giving you the total request as well. So this green is your traffic. So in a single chart, you are having the traffic as well as the availability and a threshold, and that's how you can build your error budgets, etc., because this gives you now very good visibility on how your application is performing. This is latency, and let's look at what metric we went after for looking at this. The Kubernetes container server response latencies. That's the metric that gives you this information, and we have aggregated by 95th percentile and by destination workload, and that's what you're seeing here. The green line is your number wiki, and blue is math functions. Now notice, of course, that number wiki has a higher latency and math functions has a lower, because of course one call number wiki calls a math functions like 14 times, right? So of course number wiki has a higher latency here, and that's the threshold that we have set, and these are things that you will use to really set your SLOs and error budgets around observability. Let's now move over to Grafana and build a golden signal dashboard for Grafana. Now I've already put this in place to save time, and I'll walk you through what has gone behind it. This is similar metrics, the same data that is available in Grafana as well, right? If I do an edit, you see GCP monitoring, and you look at the matrix that we have gone after. This is exactly similar to what you saw, exactly same as what you saw in the GCP native dashboards as well, and again grouped by the destination workload and so on and so forth. The reason we are doing this in Grafana as well, Grafana gives you a lot more flexibility around a lot of different kinds of visualizations that you can build. It's a powerful industry recognized tool, but the point being, you can the main point I want to make with showing Grafana is you can have all of these logs and the matrix exported to any tool that your industry, your client, your company might be using, and you should be able to build the golden signals and other telemetry or observability visualizations using the data that you can throw in the third-party tool. And this is again traffic good versus bad requests. Take a quick peek at how we built this. Again, we went after the same Istio request total, and we applied the same kind of filter like we applied in the GCP native dashboard. All right, we went after the response code 200 or response code not equal to 200. Similarly, on CPU utilization, we picked up the CPU utilization from the metric it was available in, and that's from compute, because this is going after the node CPU utilization, and this one is latency, and this was similar to what we saw in GCP native dashboard. This is I think looking at Istio server response latencies, and that helps you build this chart here. So that's your golden signal dashboard in Grafana for your apps running in GKE. Here is the recap of what we did today. We reviewed the GKE cluster up and running. We looked at the demo apps, number wiki, and math functions. We looked at the Kubernetes manifest files. We did a quick walkthrough of all the three YAML files that we use. One for namespace creation, one for math functions, the other one for number wiki. We then deployed the apps using kubectl from the CLI. We validated the apps and we induced traffic. We reviewed the out-of-the-box observability dashboards for GKE. And then finally, we built Golden Signals dashboard, both in GCP native as well as Grafana. Well, friends, that brings us to the end of this video on building observability for apps running in GKE. If you like the content, please do subscribe the channel, hit the bell icon to get notifications when new videos are posted. If you're genuinely interested in learning all the foundational skills we have been looking at on Everything Cloud platform, stick around and follow along all the videos that are posted. I'm sure you had a wonderful time in this session, and I'll see you in the next sessions here.